So today I will introduce my final project, which is predicting lending club loan charge-offs from initial listing data. So I obtained the dataset from Kaggle, and Lending Club is a United States peer-to-peer lending company and the world's largest peer-to-peer lending platform. The Lending Club enables borrowers to create unsecured personal loans between $1,000 and $40,000. The standard loan period is 3 years. Investors can search and browse the loan listing on Lending Club website and select loans that they want to invest in based on the information supplied about borrowers, amount of loan, loan grade, and loan purpose. Investors make money from interest. Lending Club makes money by charging borrowers an orientation fee and investors a service fee. And then I do the important data. So in this section, uh, there are 2.2 million rows and 144 variables. The size of the dataset is 2.4 GB. And then I do the response variable step. So we are going to try to predict the loan status variable through a simple analysis of response variables. We found that about 79% of the remaining loans have been fully paid, and 20% have charged off. So we have somewhat unbalanced classification problem. And then I do the limit the feature space step. So the full dataset has 150 features for each loan. We will select the features in two steps. The first, we drop features missing more than 30% data. We say there's a large gap between features missing some data, which is lower than 20%, and those missing lots of data, which is greater than 40%. Because it's generally very difficult to accurately impute data with more than 30% missing values, so we drop such columns. And then I only keep loan features known to potential investors. So we examine the lending club website and data dictionary to determine which features would have been available to potential investors. For each of these features, we check the description in the data dictionary and only keep the features that would have been available to investors considering an investment in the loan. This includes features in the loan application and any features added by lending club when the loan listing was accepted, such as the loan grade and interest rate. I'm using my best available knowledge to determine which loan features are known to potential investors. I'm not an investor on Lending Club, so my knowledge of the Lending Club investment process is not exact. When in doubt, I err on the side of dropping the feature. And then I do the pre-processing and exploratory analysis step. We will inspect each feature individually and do the drop the feature if it is not useful for predicting the loan status, and view the summary statistics and visualize the data, plotting against the loan status, and then modify the feature to make it useful for modeling if necessary. So, and then I do the more pre-processing step. First, I convert the launch status to 0 to 1 charge-off indicator. So change the response variable launch status to a 0 to 1 variable, where 0 indicates fully paid and 1 indicates charge-off. And then I do the create dummy variables. So there are no categorical variables with missing values, and therefore we don't need any non-dummy variables. And then I do the trend test bait. So we will make our modeling problem more realistic by performing the trend test based on the months that the loan was funded. That is, we will use the loans funded on earlier dates to predict whether future loans will charge off. The variable issue D includes the months and year that the loan was funded. So then I do the linear dependence of charge-off on the predictors. So on the training set, we compute the Pearson correlation F statistics, and p-value of each predictor with the response variable charge-off. And then I do the most important step, which is model training and testing. We implement machine learning pipelines consisting of one or more of the following steps, depending on the particular model. So I do the mean imputation of missing values, and then I do the dimension reduction using linear discriminant analysis. Um, Third, I do the data standardization with calling to zero mean and unique variance. And the fourth is just to choose a model. So we will evaluate and compare the following models using a cross-validated AURC score on the training set. The first is logistic regression with HJD training, and second one is just like random forest, which is my second model, and third one is just KNN. So we will perform some hyperparameters tuning for each model to choose the most promising model, then more carefully tune the hyperparameters of the best performing model. So for the conclusion, we applied machine learning methods to predict the probability that a requested line on landing club will charge off. After training and evaluating three different models, we found that all three performed similarly according to a cross-validated AURC score on the training data. We selected logistic regression because it was the fastest model to train, and this model obtained an AURC score of 0.709 on a test set consisting of the most recent 10% of the loss. This model, while far from perfect, can provide a somewhat informed prediction of the likelihood that a loan will charge off, using only data available to potential investors before the loan is fully funded. We also found that, according to a linear measures of correlation between the predictors and response, the most important variables for predicting charge-off are the loan interest rate and term, and the borrower's FICO score and debt-to-income ratio. So that's all the introduction about my project. Hope you enjoy it. So I have a good time with it. Thank you.